Hello everyone, if you like my video, please subscribe, like and share it for watching upcoming videos. Thank you.
Hello students, I hope everyone is doing well. Today I am going to continue with the same lesson, and today is the topic I am going to discuss, that is the action of ammonium hydroxide on certain metallic salt solution. Now in this regard, let me say you, in the last class I had a talk action of sodium hydroxide solution on certain salt solution, metallic salt solution. Today I will continue with the same, but with I have changed the reagent from sodium hydroxide to ammonium hydroxide. Let us see what are the difference they form in certain salt solution. So first, what is the basic of this, that when ammonium hydroxide behaves as a reagent here, when it is added to the salt solution in little amount, then what happened? In little amount when it is added, then what happened? The precipitate form of the respective salt. If it is representative element, then it will give the white PPT. If it is a colored element, the transition element, then it will give the respective colored PPT in the form of hydroxide. Plus the another salt in the double decomposition, what is the another salt that will be formed. But when this PPT will be treated with excess amount of NH4OH, that is the same reagent, then few of the salts you will find that, few of the hydroxide you will find they remain insoluble in only, but few of the salt cations you will find that they become soluble. Now why they become soluble, few of the salt? Because of the formation of the soluble amino compounds. You have to remember this, soluble amino compound. Amino compound is what? It is one type of complex salt, and you know all complex salts are soluble in water. Now let us see the first salt. First salt we will deal with the calcium salt, that is Ca2+. When we are treating with the sodium hydroxide, we find that the calcium hydroxide is forming, which is a white PPT, and it is insoluble in, sparingly soluble in excess of it. But in ammonium hydroxide, this has no visible reaction takes place. Okay, students, in this chapter you will be learning both the reagents, how they behave in the certain salt solution, and the distinguishing characters often comes in the exam. You have to remember that what is the behavior of the calcium in small amount of ammonium hydroxide, small amount of sodium hydroxide, in excess of ammonium hydroxide, in excess of sodium hydroxide. So you have to remember nicely both the salt solution in different reagents, how they behave differently. Let us see. Some of the salts will behave same, some of the salts will behave different. Why it is not giving any, in the NaOH it is giving the reaction, but here it is not giving reaction because it is a very low alkali. You know very well it is a weak alkali, so it cannot react with this. Now coming to the next, that is the, let us go to the iron. Iron, you know, Fe2 plus is there, Fe3 plus is also there. So let us discuss first with the Fe2 plus. When FeSO4 iron, it is ferrous sulfate is a green color salt. When reacts with ammonium hydroxide, gives what? Ferrous hydroxide, it is a precipitate, plus ammonium sulfate. Now you have to balance it. I think it is balanced. Okay, now it is a solution, it is a colorless solution, and it is a dirty green precipice. Now, and this is also colorless. Now what happened? This is in small amount when we add. When we will add in excess, then what will happen? In excess, we see that the dirty green precipitate remains insoluble only. You remember in the NaOH also it remains insoluble, that means they are behaving same in both the cases. Now coming to the Fe3 plus. Fe3 plus we will see that, let us take FeCl3, it is a yellow color solution, okay, plus NH4H gives what? Again the hydroxide will be formed. Fe, this time it is a ferric, and it is a reddish brown, plus NH4Cl. Now you see FeCl3 and NH4Cl, that means here it will be 3 and it will be also 3. Okay. Now in this way we see that reddish brown PPT is forming with NH4OH. But when we add in excess, then what will happen? It remains, the brown PPT remains insoluble. That means it behaves the same with the Fe2 plus also and with the Fe3 plus also. Let's see the next one. Next one is the copper salt. Cu2 plus. CuSO4 plus NH4OH gives copper hydroxide, okay, plus ammonium sulfate. Okay, I think it is balanced. Now, it is a precipitate, but copper has a pale blue. When it is added, little amount. Now, when in excess, the reagent will be given, then what will happen to the precipitate? The precipitate will be there, or it will become soluble. This one, it remains insoluble. Here also we will find that it remains as a precipitate. When it is forming, it becomes this copper hydroxide. When again reacts with, let us see, when copper hydroxide again reacts with excess of NH4OH, it gives what? A complex salt is formed. That is CuNH3 whole 2 and hydroxide plus H2, you balance it. What is the name of this? Tetraamine. How many amine are there? 4. So tetraamine, then copper hydroxide, and it is what? It is a complex salt, and I told you that excess of the complex salts are all soluble. And what will be the color? Because we know pale blue PPT is formed, and now the color will be changed to deep blue solution. So this is the huge difference between the ammonium hydroxide with copper ion. Sodium hydroxide case, we have seen that they are insoluble in excess also. With the zinc salt, we will see Zn2 plus. We will see that how zinc sulfate plus ammonium hydroxide gives what? ZnOH whole 2. And you know zinc is a what? Which metal? It is a representative element. So it is forming a white precipitate. And what is the white is there? Gelatinous. And another salt will be ammonium sulfate. Clear? Now you balance it. Forms a white gelatinous precipitate. Now excess, what will happen? This zinc hydroxide with excess of this ZnOH whole 2 plus NH4OH, that is in excess I am talking. It is excess now. And this is the little amount. And this is the excess when we give. Then what happened? Again with the same case like the copper we have done, it forms a soluble amino compounds. So it will form the same thing, tetraamine zinc hydroxide solution plus water will be given. Now you balance it, and here also it. The name of this then, tetraamine zinc hydroxide. Tetraamine, NH3 is amine, tetraamine zinc hydroxide. So it is a complex salt and it is soluble in nature. And what will be the color? It is the color of the salt, obviously. It is a white salt. Now coming to the last of this, that is lead. Lead salts, we will see the lead ion, how they are reacting. Let us take one soluble salt. Lead nitrate plus ammonium hydroxide. They will give lead hydroxide. It is a PPT. And lead is a representative element, so it white PPT. It is little amount. Okay. Now, what will be happening? and giving the next of the ammonium nitrate. When we start adding it in excess, we find that it remains, no changes there. The chalky white color remains insoluble only, no change. In the sodium hydroxide reagent, we use ammonium ion. Ammonium ion we cannot use here because here the two cations will be the same. We will see certain compounds which behaves a little bit exceptionally. Which are the compound? Let us see. The next topic we will discuss about the action of alkalis on certain metals. Which are the metals we are going to discuss in this? Zinc, lead and aluminium. Why we are telling? Because you know they are amphoteric in nature. Because these are the metals which reacts with both acid or base to give salt and water. And these metals, their oxide or hydroxide give the respective salt and water. What about the metal? Metal will give the salt, soluble salt. Since all these metals are above hydrogen in the activity series, so all these metals will give what? Hydrogen gas when reacts with the respective alkali. Now let us see with the example. First we will talk about the zinc. When zinc reacts with NaOH, they give the respective salt will be given. The salt will be not a normal salt, it will be a complex salt. So it will be Na2ZnO2, sodium zincate, and since it is a soluble salt, so it is a color. It becomes a colorless metal reacting with the alkali, giving the complex salt as well as hydrogen gas since they are above hydrogen in the activity series. Similarly, we can take with the aluminium also, Al plus, and what condition will be there? What are the conditions here? Hot and concentrated. You have to remember this. The alkali should be hot as well as concentrated. You know what is concentrated? It should be totally pure. Okay, no dilute. Okay. Now, in these two conditions only, they will give the respective soluble salt, that is the complex salt, and as well as hydrogen gas will be liberated. Next, we will see with aluminium. Water has been added here because to make it a soluble. Okay. Sodium aluminate. 2Al plus NaOH gives sodium aluminate, that is Na3AlO3. Now the name is what? Sodium aluminate. It is a soluble salt plus hydrogen gas will be liberated. And it is also soluble and it is a soluble salt. Okay. The next we can do with the third metal, that is the lead. Lead also can do the same thing. NaOH gives Na2PbO2 plus H2, sodium plum white. Students, you have to remember these all names because these are the forming complex salt, these are not forming normal salt and all are soluble. In this way we see that these are the special types of metal. Alkali reacts on this metal and give the respective complex salt and hydrogen gas is liberated. Now coming to the amphoteric nature of these certain three metals. Now students, we are going to see that action of alkali on metal oxides. Now we know that normally metal oxides and hydroxide neutralize with acid to give salt and water. But these three metal oxide, zinc, lead, aluminium, these three metal oxide or hydroxide, they react with acid also to give the salt and water. They react with alkali also to give the salt and water. So we will see here these three elements, their oxides and hydroxide behave as a dual nature. What nature? Dual nature. Dual nature means with acid also they give the same product, with the bases also they give the same product. But with the bases, will they give the same normal salt? No, they will give the complex salt, which are also soluble in nature. That's why they are also known as what? Their oxides and all are known as amphoteric. Let us see example I'm taking the zinc, and the rest of the elements you can do by yourself. First one I'm doing zinc. With the zinc, you see that normal when zinc oxide or zinc hydroxide, both reacts with what? ACl to give salt and water. ACl is acid. This is the normal balance it. Okay, so this is the normal behavior of the zinc oxide and hydroxide. But what about the alkali? With the alkali also, let us see. Zinc oxide will reacts with alkali. They give the salt. They will give the salt, but this salt will be complex salt. You know, sodium zincate is the salt. Na2Zn2. So sodium zincate plus. Now what about the zinc hydroxide? They will also give the same product, sodium zincate plus 1. So in this way we see, students, that this amphoteric oxides and hydroxides are dual in character. They react with acid also to give the salt and water. Those salts are normal salts. They react with alkali also to give the salt and water. That salt is complex salt, which is soluble in nature. In this way, the other two also you can practice in your home copy. So students, with all this I have come to the end of this chapter. I hope you have understood the chapter nicely. Please practice the reaction given in the book and try to memorize the box of the metal cations with their colors of their precipitate. That's all for today. I will give the question answers in the coming PDF. Keep learning. Have a good day. Thank you.